Okay, so in 7.5 number 12, I would like to know, are these functions periodic? And then they give me some functions, and I think I got B and C backwards on here. I think that's one C, and this one's B. But whatever. Point is, I want to know, is sine of minus t periodic? What would your answer for this be? First, what does periodic mean?
It repeats.
Yeah, it repeats. So periodic, right, should mean that f of t is f of t plus some constant, and that constant has to be bigger than 0. What does this mean in shifting land?
It means if you shifted your function over.
Yeah, it means if you move your function left by c, you get back the same picture you had, right? So that's an easy way for me to check. I could just look at the picture and be like, okay, would a left shift ever be the same thing as the picture I've got? You guys with me on that? Another thing I could do is I could do this, right? I could take sine of minus t and set it equal to sine of minus the quantity t plus c, and then try to see if I could find such a c. You guys with me on that? Yeah. Okay.
I don't understand why you added the C.
So that's just me thinking about what periodic means. This is the definition of periodic algebraically. Graphically, the definition of periodic is if there's some little bit of function happening, right? That little bit has to repeat exactly in every section. So these all have to be the same. And then this distance here is called a period. That's that C value up there.
Okay.
So that's another the algebraic approach would be saying the function you're looking at is a left shift of itself. In other words, if you take all these things and click them one space to the left, you get exactly the same picture you have. I don't really care which approach you use for these, but one of them. So if you sketch sine of minus t, what do you get? That looks like sine, right? With a,
A flip. Some sort of flip.
yeah, that's a
Over
flip
the
in the
x-axis.
x direction, which is over the y axis.
Right, okay. It's after the.
Another thing you could do is you could say, that's minus sine of t, right?
Oh, yeah.
Because sine's odd. Oh, and that's a flip over the x-axis. So you're not wrong, Zach. You're just right for the wrong reason. On this one, a flip over on sine, right? A flip over the x-axis and a flip over the y-axis are the same
exact
thing,
Sorry.
right? So it doesn't matter which one you do. So what I get is a picture that looks like sine, right? And then what's going to happen over here?
Same thing.
Same thing.
Yeah, it's going to be the same thing. Oh, okay. This one's periodic. Check. And then what's the period?
The,
How long is one of these guys?
From pi, 2 pi.
2 pi,
2 pi. So 2 pi.
right?
Yeah.
Because that's one rev around the unit circle, right?
Yeah.
And I didn't speed it up or slow it down, so that's a 2 pi period. Check, period is 2 pi. First one. Okay. Let's see. Other things that look like obviously trig functions. Like which one of these other ones is going to be the next easiest one? C? Those guys?
It's just a regular sine function shifted up by t.
Up by t.
What does
Oh,
that mean?
t is.
Variable.
How about this? What if I thought this is the usual, oscillating sine curve, right? And then what's t look like as a function?
A line.
It's a line with slope,
0.
no,
1.
1, and intercept, 0.
Oh, it's the y.
It's the line g of t equals t, right? It's the line y equals x, basically. So that's going to look like this. So if you take this thing and add that thing,
It's gonna.
what are you going to get? Yeah, like wiggly stairs. Nice,
Oh, nice.
right? Are wiggly stairs going to be the same if you shift them left? Right, so I'm looking at something like, yeah, there's not going to be a shift left to this, right? That's going to give you the same picture, because if you shift it left, you're going to get something like this, right? You're never going to get the same picture unless you don't shift left, right? So this thing is
Not periodic.
not periodic.
Is that because it's, you have a sine function in a line?
Yeah, it's that you're adding a function that's periodic to a function that's not periodic. Most of the time, that's not going to be periodic.
Okay, that makes sense though.
Are there any exceptions? If there is, very complicated, then don't have to.
No, there will be no exceptions to that. That's because, right, if I'm thinking algebraically about this, if I have, say, h of t that's made out of f of t, like a periodic function like I have, plus g of t that's not periodic, not periodic, right? If I think about h of t plus some constant c, right? I'm hoping to get back to h of t, but the way I make big H of t is I do little f to f of t plus c, and I do g to t plus c as well, right?
Yeah.
These guys I can make the same, right? Because f is periodic,
Mm-hmm.
right? So I could use the period of f to make those two guys the same.
Right.
But if g's not periodic, there's no way I'm going to make this part match.
I see.
You guys see that? And that takes a little bit of work.
Matching the not periodic.
Yes, saying that that's enough to prove this is not quite right. Right? Because it could be such a case that this part might match both of those, right? Like if you picked a different C, you might be able to get this one to match part of. It's not going to work anyway, but yeah, that argument's a little harder than what I'm making it look like. Cool.
Fair.
But basically the gist is you couldn't get the pieces to match.
So no exceptions.
What's that?
No exceptions.
Yeah, no exceptions. Okay. How about h of t is 4 times cosine of pi t?
That is stretched
It
amplitude.
is.
Yeah, I expect that to be periodic because that's a periodic function with a, what's pi times the
It's a
t do?
magnitude. Isn't it? Make it it's a horizontal.
That's a horizontal compression, right?
it's
So
gonna-
I compress horizontally.
You're basically
So that's
compressing it
just
by
a
half.
cosine with different x values, right? And then what's the 4 do?
Fix it.
Vertical stretch. Okay, so I'm going to end up with a cosine function, right? That's taller than usual and smashier than usual.
Great.
But is it still periodic?
Yes.
Yeah.
Oh, yeah.
Period is pi.
Oh, and what's the period?
Oh, it's not pi though.
2.
So the period was 2 pi, right?
Oh, it is pi.
And then we smashed it by a factor of 2, so now it's
2.
2.
You mean we smashed it by a factor of pi?
Yeah, we did a horizontal compression by a factor of pi, right?
Okay, you said.
Oh, yeah. Oh, right.
So I had 2 pi,
and
and I
compressed it.
smashed it by 2, so I'm left,
No, you
or
smashed-
sorry,
you
I
smashed
smashed
it
by
with pi,
pi,
and-
and I'm left with 2.
Yeah.
Yeah, I'm dividing the period by pi. You guys cool with that? Sorry about my massive misspeaking there.
No, that's alright.
All right, how about sine of t over 2?
It's the same as C. I think, right? Because you have two functions,
Yeah, it's almost the same as C.
but now you have a definitive value for the line, right?
Okay, so
It's a straight line.
hang on, because this falls into this thing I was talking about earlier about a periodic function and a not periodic function, right?
And now,
Except it doesn't.
Yes.
Because 1 is a periodic function,
so,
right? 1's a horizontal line.
mhm,
Any left shift of that at all
is a periodic function.
gives you back itself, right? So 1 is a periodic function. It has an arbitrarily small period, which is a little bit bizarre. What's that?
Is it? It's not infinity to infinity.
So I said a periodic function meant this, right? The function 1 has this true for any C value at all, right? So its period is very, very small. Maybe you would say that its period is 0, but that's a little bit weird, right? At any rate, I can think about this in graph land, right? As this guy's a horizontal stretch, and then this is a
Shift up.
vertical shift, as opposed to a shift up by a varying amount, right?
Yeah.
I shifted everything up consistently, that's gonna preserve that periodicity, whereas you shift it up by some randomness, that ain't gonna do it. Cool? What's the period on this one? Okay.
4 pi.
Nice.
Double.
Cool question?